Evening. Today we are going to discuss Liang Barsky's algorithm. Here, the main features we are using here today are pill command for drawing the images on our window, and we are using the Liang Barsky algorithm as the name suggests for our today's lecture. Now, the basic concept here are if pk equal to 0, then parallel to the line clipping boundaries. If pk equal to 0 and qk less than 0, it's completely outside the boundary. If pk equal to 0 and qk greater than equal to 0, and inside the parallel line clipping boundary, if pk less than 0, then line proceeds from outside to inside. If pk greater than 0, line proceeds from inside to outside. That's the basic concept, where pk stands for p value and k is between 1, 2, 3. That's why we have declared here a p array of size 4. Now, the basic algorithm, as it says, we have to declare t min to 0, t max to 1, and then we need to calculate the t left, t right, t top, and t bottom. If t less than t min, we ignore and move to the next edge, else we separate the t value as entering or exiting value using the inner product. If t is entering value, set t min equal to t. If t is exiting value, set t max equal to t. As you can see here, we have done the calculation portion here. Now, we can go to the next step, where if t min less than t max, we draw a line where x1 plus t min and the product of their difference in x coordinate, then y1 plus t min into y2 minus y1 to x1 plus t max, x2 minus x1, comma, y1 plus t max, y2 minus y1. If the line crosses over the line, x1 plus t min and the change in x, comma, y1 plus t min into change in y, and x1 plus t max into change of x, comma, y1 plus t max into change of y are the intersection point of line and edge. Now, Liang Barsky algorithm overcomes what we have got as a fault for Cohen-Sutherland. Now, here we have used pill command basically to draw our images. We have gone directly to the Liang Barsky algorithm here, but before that we have defined our boundaries here. As you know, only 2 points are more than sufficient to show our rectangle because we are working on a discrete space. Now, also we have calculated, because P0 means Pk is equal to x2 minus x1, that's minus of x2 minus x1, p1 equal to x2 minus x1, p2 equal to minus of y2 minus y1, p3 equal to y2 minus y1. Similarly, q0 is calculated as x1 minus x min, that's the big list value of x, x1 equal to q1 equal to x max minus x1, q2 equal to y1 minus y min, q3 equal to y max minus y1, where y max, x max stands for the greatest value of x and y which are attended in the rectangular box, while the x1 and y1 are the corresponding values which we have given, and x2 and y2 together are the location of the points from which we are taking, for which we are clipping, while x min and y min are the smallest point in our rectangular polygon. Now we have used a for loop here to calculate our t values, and we are substituting it. The default t values what we have taken here are 0 and 1 because as it's the what the algorithm suggests us. Now we have drawn the line from these 2 points, between these 2 points, and I have made another method to show you what the line will look like without clipping and with clipping. Now let's go to the images. As you can see, our first image here shows us the rectangular box with all lines crossing over it. The rectangular box here is our window, but it is crossing our window's area boundaries. That's why we need to follow Liang Barsky algorithm. So when we apply the above algorithm, we get a diagram like this, where everything lies inside the window, and as you have seen in earlier diagram, the extended lines were shown in green, but now the white lines are cut down and it's inside the boundary. Thank you for today's lecture.